Okay, it's already recorded now. So we get started with the video. I'm going to share it. Be ready with your pens, books, and then we get started. Huh?
Yes, teacher.
Okay.
A variety of plants and animals live on our planet. Natural resources available on Earth influence all life forms. In this lesson, you will learn about natural resources such as air, water, and soil, their importance, and the pollution of these resources. By the end of this lesson, you will be able to describe Earth as a biosphere, describe air as a natural resource, describe the role of air in control of climate, list the causes of air pollution, describe water as a natural resource, list the causes of water pollution, describe soil as a natural resource, describe the formation of soil, and list the causes
Please
of...
ensure that you have muted. Huh? The sounds that are coming out when you have not muted, you're going to be disrupting others. Huh? Have we done so? Probably so. I think I need to just mute you guys. Okay, so guys, you only need to raise your hand and then I allow you to be. I mute you and then also you can now unmute yourself. So let us. Yeah, okay. So now I think you have seen the aims for this lesson. We are going to learn it all. It's going to be very easy and then it's much more applicable. Even today we're going to discuss about the oxygen concentrators. I think you've heard in the hospitals that people are looking for oxygen. How is oxygen concentrated? How is it obtained from air? So you're going to have a perfect idea of how it all comes about. And you see that the science is not far from you. You can really explain it to anyone at home and see the major source of oxygen. It's just absolutely air. How do they pick it from air and then they force it for someone to breathe in? So it's what we're going to learn today. So be ready and then enjoy the video.
soil pollution.
Hi there. How are you doing today? I'm here to join you on an exciting ride to learn something more about the place we live in, Earth, and its resources. Do you know the 3 important natural resources of Earth? I don't. So let's find out.
The resources available on Earth are land, water, and air. The solid outermost layer of the Earth's crust and the rigid upper part of its mantle is called lithosphere. The water that is found on the Earth's surface, above it as clouds, and below it as groundwater, is called hydrosphere. It constitutes 75% of the Earth's surface. The air that covers Earth like a blanket is called the atmosphere. The region of Earth where the atmosphere, hydrosphere, and lithosphere interact and support life is called the biosphere.
Wow, I didn't know that. But I know what bio means. Bio means life. Let's find out more.
The biosphere has two components, biotic and abiotic. Living organisms constitute the biotic component of the biosphere. Air, water, and soil constitute the abiotic component of the biosphere.
Okay, so that means the biotic and abiotic components need each other, right? Living organisms need air, water, and soil to live.
The biotic component utilizes natural resources like land, water, and air to survive. Air as a natural resource. Air is a mixture of gases like nitrogen, oxygen, carbon dioxide, and water vapor, which support life. Let's now focus on the atmospheric gases that are used on Earth, like nitrogen, oxygen, and carbon dioxide. Nitrogen is used to produce a number of organic molecules like proteins. Nitrogen is fixed in plants and is transferred to animals through the food chain. Plants and animals use oxygen for respiration. Combustion of fossil fuels also requires oxygen. The other important atmospheric gas, carbon dioxide, is mainly used by green plants for photosynthesis to prepare food. Marine animals absorb atmospheric carbon dioxide and form carbonic acid. These carbonate ions are used by marine animals to make shells.
I couldn't live without oxygen. Oh, there is more that air does for us.
That's right. Air helps to maintain a steady temperature on Earth during the day and controls the climate and the formation of rain. Let's see how. Here are 3 beakers. The first is filled with water, the second with soil, and the third is left empty. A filter is placed in each of the beakers. The beakers are placed in sunlight 3 hours, and the thermometer readings are taken. Notice a difference in the readings. The temperature reads more in the second beaker than in the others. This indicates that soil gets heated faster than water and air. If we perform the same experiment under shade, this is how the temperature stands. This time, the temperature reads more in the first beaker than in the others. This indicates that soil gets cooled faster than water and air. Since soil gets heated faster than water, the air above land also gets heated faster than the air above water bodies. During the day, heated air above the land starts rising, creating a low-pressure area. This causes air to move from a high-pressure area over the sea to a low-pressure area over the land. This creates a sea breeze. This is the reason why land near water bodies gets colder faster.
Cool. That's why I like the seaside best. But if all this happens in the day, what happens at night?
At night, since soil cools faster than water, the air above the land is cooler than the air above the sea. This causes air to move from a high-pressure area over the land to a low-pressure area over the sea, creating a land breeze. However, it is not only the temperature, but some other factors that are equally important, like rotation of the earth, presence of mountains, altitude, etc. Apart from causing land and sea breezes, air also helps to form rain. Let's see how. Water bodies get heated during the day and water evaporates into the air. Hot air rises and carries the water vapor with it. As the air rises, it cools. This causes the vapor to condense into tiny water droplets. When these droplets grow bigger, they fall down as rain. This process is called precipitation. When the temperature is low, precipitation may occur in the form of snow, sleet, or hail. In many parts of India, rain is brought by seasonal winds called monsoons. There are two types of monsoons, southwest and northeast. Southwest monsoons brings the maximum amount of rainfall for India.
Maximum biodiversity. These regions have moderate rainfall, while these areas receive low rainfall and show minimum biodiversity.
The contamination of air with chemicals, smoke, dust particles, and disease-causing agents is called air pollution.
No wonder I have been coughing all day. We should stop polluting the air. But before that, let's find out the causes.
Burning of fossil fuels contributes to the addition of suspended, unburnt hydrocarbon particles into the air. Fuels like coal and petroleum also release nitrogen and sulfur oxides. These oxides of nitrogen and sulfur dissolve in air and form acid rain. Breathing of this polluted air causes allergies, cancer, and heart diseases. Now, let us look at another natural resource, water. It is found on the Earth's surface, under the ground.
I just hope that we have learned something about air, and everyone has seen, where does it all start from? We have heard about the lithosphere, something that is new that you can speak at home and then intimidate people and say, what is lithosphere? They have understood what's all about atmosphere. We say that the air that covers the entire Earth as a blanket, what happens is called atmosphere. And then sometimes in physics, you have a different definition. But the first bit is all the air around the Earth makes up the atmosphere. So what happens there? What's all about this air? You say that air is a mix of gases. And knowing as a mix of gases, I want every one of you here to list for me about six gases that you hope that are found in air. Okay, so I have Marilyn, I think. Let me see. And I'm starting with Gaba, you give me two, and then Marilyn also gives me two. So I've unmuted you. Gaba, I'm listening to you.
Oxygen,
Louder, please.
Oxygen and nitrogen.
Oxygen and nitrogen. So thank you. That's perfect. And then Marilyn.
Carbon dioxide and rare gases.
Carbon dioxide and rare gases. So you have oxygen, nitrogen, carbon dioxide, and rare gases. So those are already 4. I need an extra 2. So I'm going for Amal.
Teacher,
Yes, my dear.
argon and krypton.
Argon and krypton. It's called argon and krypton. So yes, perfect. So, and then Karunji Shiba.
Hydrogen.
Sorry?
Hydrogen.
Hydrogen. Okay, yeah, it may be there, but in very little amounts here. So any other besides, I'm done with Angela. I'm looking at Angela here. Okay.
Teacher, is it argon and rare gas?
Argon and rare gases, yeah, it's already been mentioned. Thank you. So here, Naigaga. I'm looking at Naigaga.
Teacher, it is.
Sorry? Naigaga, I'm waiting on your response, my dear.
Neon.
Okay. Okay. So all those are rare gases that you're mentioning. Thank you. People know rare gases. Oh Lord. So now, what have I said? First thing, defined as a mix of gases, and can we list the components of air, all what makes up a mixture? We are saying that one, we have, someone says that we have nitrogen, we have oxygen, we have carbon dioxide, we have rare gases. After having rare gases, we are saying that we have also water vapor. Do you know the mist that we always find? Whenever it gets cold early in the day, always that's called, it's called water vapor. We see it as fall, dew, whatever you find, how you call it, where it comes from, but it's always called water vapor. Water vapor is part of what? It's part of the air. So meaning that how many components have we mentioned so far? There are quite a number that make up 7. So among us, the rare gases, there are many rare gases that you can find, like the xenon people have been talking about, the helium, the krypton, all those are quite like rare gases. So now we're going to look at that. Besides that, people, you can put down their hands. Let me just see here. And then I share something here. Okay. I hope that you have yours there. So this is what we have in our notes. They're saying that air is a space above Earth is. I think that one is already mentioned. I won't be bored. You've already seen how it comes about. Clean air has a specific composition of gases that can be expressed in percentages. What does that mean to us? I've already listed about 7 components of air. Among those 7 components, each of them are not in equal quantities. Why aren't they in equal quantities? Do you remember when we were covering things to do with mixtures? Mixtures, you say that you can get two or more substances, you physically combine them just by your bare hands, you just mix them. So air was just mixed by the hand of God. So having different components, meaning that what happens here? In this case, this composition of the components that I've said, the nitrogen, the oxygen, and what, all of them are not equal in amounts. When you ever test air as a mixture, you're going to find that, yes, we know that there are 7 components that make up air, but each of them, they are not equal in amounts. You're going to find that some are greater than the other. So what do you remember? I remember in your primary, you say that there is a gas that is the most abundant when you check all the composition of air. you're going to find there is a gas that is more in air than any other gas. Who can remind us about that gas? Anyone? Okay, so I'll take Ndagiri. I'm picking Ndagiri. Which gas is that? Ndagiri, are you there? Or Najin can help out?
Nitrogen. Nitrogen.
Nitrogen is the most abundant. But do you know the percentage of nitrogen, by the way? By how much is it more than others? What is it? Anyone who can guess, right?
78%. 78%.
78%. That's a huge amount, meaning that our guys, you can put down their hands. Okay. We're saying that here. That's a huge amount, about 78%, meaning that almost the entirety of air, the entire bit of air is mainly nitrogen. Why? Because nitrogen comprises or makes up the biggest proportion of the air. That's one idea. There are others that follow next, as we're going to see. What am I trying to give in? I'm trying to explain that clean air has specific composition of gases that are expressed in percentages. Percentages, what do? They try to indicate how much of this gas do you have in the entire air. So the composition of air has its natural importance and supports different forms and then processes that take place in what? Air. You have named a lot of processes. So can you tell me about the processes that you know that are supported by air? I think I need about 4 processes. In the video that we have watched, there are about many of them. Okay, so I'm going to start. Okay, I'll be selecting you. So those ones who have already, I think I'll be giving opportunity to others. Let me see which one here that we shall have. Who has ready? Raise the hand. We shall have Batamuliza Kaplan, is it? Like that. Give me one that you know is supported by air.
Respiration.
Sorry?
Respiration.
Respiration. Yes, one. We always breathe. You know, respiration is all about breathing, isn't it? So that is one. Della. Is it Della? Umpire or something? Okay. Della, be quick, please. There are many people that are burning with their answers. Yeah. Okay. Okay, if Della is not there, we have Kamsange. Kamsange, give me. Is it the network challenge, my dear? Combustion. Yes.
Combustion.
Burning of. Thank you. Whenever you burn substances, they need a certain amount of air, and that air probably is oxygen. You know, combustion is all about burning substances in air. And what gas that supports burning? It's always oxygen. Where do we find it? Already in the air. So that's one process there. Another process we have, there was one, Namicho. Is it Namicho? Yeah. So Namicho.
Photosynthesis.
Absolutely. Photosynthesis. Can you tell me what's all about photosynthesis? Sorry? Someone needs to climb a tree, by the way. Yeah. The network is, the signal is dropping. Okay, so you can have another one. Is it Kamit? Kamit. Kamit, are you there?
Teacher Rusting.
Sorry. Rusting, yes, perfect. All right, so those are quite enough as we may proceed because we have to cover a lot. All right, so I was trying to say, we can put down the hands. That means that we have a number. I need you to have about 8 processes that are supported by all the components of air. These are questions that are going to be coming. The introduction already, the video now is trying to, I told you to note many things. We have seen the rusting, someone saying rusting, the combustion. Have you seen formation of seashells? What happens in there? They all need air, carbon dioxide from the air. Carbon dioxide is being used for photosynthesis. We have seen, have you known why we see when you always be by the lakeside, have you seen why you see the tides coming towards closer to the shores? Yeah, you see the water waves coming closer. Yeah, you feel the sea breeze. You know what they call a breeze? You have seen how does it come about in that video. And that one will help us much more in physics to explain why do you even know that concept of the sea breeze will also help you to know why does sound travel faster during the night than during the day. Okay, so we are going to see all this. So here we're saying that the next part that we have, probably, please lower your hands, guys. Yeah, at the time. All right, so I'm saying that this composition of clean air has its natural importance that supports different forms of life and processes that take place in air, which I think that we have explained better. This composition has its natural means of maintaining the balance. So what do you mean by maintaining balance? It means that despite the fact that air has different gases, different components, and each of them has its own amount in air, there is a way all these processes that are happening are designed in a way to maintain that those percentages do not change. Those percentages do not change. Why don't they change? Because we need to create a balance, and then by you maintaining those quantities by not changing, you create what they call a cycle. You form what they call what? A cycle. A cycle is like things keep on, yeah, there are processes that happen, but eventually you go back to the very first place that you started with. There's nothing that changes. So here, what am I trying to say? All the processes that you have mentioned, they help in a way to maintain that the quantities or the amounts of composed of air do not usually change. In this chapter, you'll be expected to get air as a mix of gases in which oxygen is the active constituent, the one that we shall focus on much more than any other at the time. Okay, so in which oxygen, like that. So here, we are looking at air in that case. This is a pie chart. Everyone knows the pie chart in math. It's going to be telling us the amounts that we usually have. You find that nitrogen has the hugest proportion, which is 78%, as it was told by some of us. We have oxygen that follows next. What does it follow next? It has a percentage of 21%. And then all other components are the ones that keep on using the remaining percentage. The remaining 1% is divided among mainly the rare gases such as argon. People that we are talking about, argon is part of the rare gases, or what they call the inert gases. A little carbon dioxide is there, which takes about a proportion of 0.3, like that. It's in less amounts. Also, we have small amounts of noble gases. I've already been telling you about the krypton, neon, and then so on. So that's all we talk about air. People, that one is important. You list the components of air and then their percentages probably. So composition of air. The composition of air changes very slightly from day to day, and also depending on the place to place. For example, look at this. Let me take a case that I'm having. I'm going to consider a classroom. When you're seated in class and I look at a forest. I have a forest and a classroom that is filled up with students. When I happen to take the samples of the air within the classroom where it's been filled with students, what would you think? Would it contain all these components of air, the air? Will they be in the same amounts? I need an idea here. Someone help me out. What do you think that you find in the air that is picked from a classroom that has been filled up with students? Anyone with an idea? Bokenya? Bokenya, are you there? Okay.
Teacher, you unmuted me now, really.
Teacher, I think you said that the class has what? Has students in it. So I think the air that you pick is going to be containing mostly carbon dioxide, because remember the students are breathing and they're taking in the oxygen. Okay, they're basically taking in all the components of air, but their body is going to use the oxygen and then release off the carbon dioxide. So I think that air is going to be having less oxygen and more of carbon dioxide and the other gases.
Okay, thank you. Nadia, what do you think?
Teacher, I have the same answers as I think the air would have more carbon dioxide than oxygen.
Okay, thank you so much. Ali, I also thank you too. I think what they said is quite so perfect. How? You're going to find that the air that you had initially, it had a certain amount of oxygen and a certain amount of carbon dioxide. But you end up saying that the amounts that you had initially, the amount of oxygen will be reducing because it's being used for which process? Respiration. Okay, and then respiration takes in oxygen and then it releases what? Carbon dioxide. So you're going to find that when I take that sample of air, it's not going to be like the original sample of air. You're going to find that the amounts of oxygen are going to be quite reduced than expected, while the amounts of carbon dioxide are going to be quite on a higher note than expected. So the next sample, I think, is going to be very much okay. When you go to the forest, what do you know? The forest here, we have a lot of green. You get it, a lot of green, the plants there, and they keep on using the oxygen for the carbon dioxide for what? The process that you told me called photosynthesis. They use it to make their own food. So as they take in the carbon dioxide, what happens here? They release a lot of oxygen. So when you take up that sample that you pick from the forest, it's going to have a lot of, the levels of oxygen are going to be shooting up high compared to the levels of carbon dioxide, because the forests keep on cleaning away the carbon dioxide because it's a raw material for them to manufacture their own food. So that's why we are saying that. Another thing, when you look at the forest, I don't know how many people have been so close to the forest. Anyone who has an idea here? The forest, have you ever woken up, when you wake up early in the morning, I don't know how many people who come from Kavali there, Kavali, anyone who is been next to the forest. I know some of us we are close to either swampland or somewhere. Whenever you wake up early in the morning, have you ever seen something that we call dew or fog? Dew or fog, or sometimes it's called mist. Do you know the reason why? Because during a certain process, some plants keep on releasing some bit of water droplets, water vapor. Anyone to remind me about that process? I need someone to remind me about the process. I need one to remind me. I think not Jinda. I'm going for Ayabazibwe. Tell me, what process do you think that allows plants to shed off some bit of water during the night? What process was that?
Condensation.
Sorry? A little bit louder, my dear.
Hello.
Yeah? Yes, my dear.
Condensation.
Condensation? Not really. Okay, it's part of the process, but the main process has a bigger name. Okay? Sorry? Okay, then I should we head to Amal. Amal, what do you think?
Teacher, I think it's perspiration.
Transpiration, huh?
No, perspiration with a P. Perspiration.
Perspiration.
Yes.
Oh, you guys, you're teaching me a lot of science here. What is perspiration? Yeah?
Perspiration. Yeah, I think perspiration is the loss of water from plants.
Sure. Okay, so I'm learning something here new. Okay, so thank you for that, Amala. So Agava, what do you add there before we move?
Teacher, I think of transpiration.
Transpiration, huh? So that's what I think also. We covered, I think in primary, remember when you had an experiment, you go to the stalk of a tree, you look at the leaves. When you look at those leaves there, what did you do? You covered it with a bit of a polythene bag, and you spent something like 30 minutes or even half a day. But what did you find out? You found out that that transparent polythene bag, it had some bit of water droplets. Huh? So it's an experiment that you carried out in primary 7. So now what happens? What am I trying to say? Whenever during the night, these trees tend to release some bit of water, and that water goes into the air in form of water vapor. And that water vapor forms some huge crystals, or we don't call them water droplets. They become so many, and then they form what they call mist or fog. And that's why sometimes, I think you ever found out, I think there is a day when you're still at school here that you woke up when we had a lot of fog and people could barely see one another. So meaning that whenever you have a lot of green, there are chances of you having a lot of fog. Okay? So the air around you is going to have a lot of water vapor. And you find that in such places, people that have asthmatic problems usually tend not to venture in being next to vegetation, because whenever you're asthmatic, you're sensitive to water vapor that is in the air. So now, next. So what am I trying to say? I'm trying to explain this part. Composition of air. The composition of air keeps on changing depending on which place you are. Someone that is next to the industry can never have the same purity of air like you do. Why? Because in industries, you know that always they give off some gases. They keep on releasing a lot of gases that keep on either being harmful or less harmful to the air. But most likely, those gases they do emit are always harmful. So when you test the air that is around, like for example, which one? Have you heard of industrial area? There is the Namamve. There is that one for, we have around here Nakawa industrial area. Those areas, when you try to take a sample of their air, you're going to find that it's going to be filled with a lot of filth. Things that you don't need to breathe. And it's not going to be that much pure. So, well, that's why I'm saying that here, the composition of air, its composition will depend where you are. When it has just rained, I don't expect the things to be the same. So its composition will keep on changing day by day on a daily basis, or varying depending on which place you are located. You can never be bragging that, okay, for us, we have this air, we have the same amount of, our air has the same purity. Because once you're not in the same place, the chances are there is always going to be some changes. So pollutants like carbon monoxide, sulfur dioxide are likely to be given out from busy cities and industrial areas. But since air is continually on the move, the pollutants get spread out around too. You know that because of the airwaves. That one I won't need to explain much. So we go to this one here, where the gist of the matter is. Let's see. Okay, so we have, sorry. Okay, oxygen. We're going to first look at the most big component of air. Oxygen. Everyone knows about oxygen is what we breathe. It's written as O2. Ever much you're not that good in chemistry, you know the chemical symbol for it, oxygen. So oxygen here is, we have seen that it makes up the next, is the second most abundant. Nitrogen is the most abundant gas in air, followed by oxygen. This oxygen is essential for many processes that are quite so beneficial. Without it, I barely hope that we can still hold our breath. We could be all dead. There are many other processes that you have mentioned. Someone talked about rusting. Someone talked about combustion. All the things happening in this world because of presence of oxygen, or they are supported by oxygen. So tell me, how would cars move without combustion? Because whenever you see anything that requires fuel, anything that requires fuel must need oxygen, because the fuel cannot burn to give you the energy that you need without using oxygen. So meaning that it's quite a blessing that we have it in the atmosphere. For example, we depend on plants, and remember, plants for food, they depend on carbon dioxide, and without nitrogen to dilute the oxygen, fuels would burn too fast for us. But the gas here, okay, before I do that, can you read through this paragraph for me? Everyone. That paragraph, everyone read about it. Mm-hmm. Maybe I believe that you're done. This paragraph is trying to show you the use of these gases. We have multiple of them, but you find that they're connected. It's like a chain that, okay, this one is needed for this, but also it helps us in this. Remember, plants, they make their food using what? They use carbon dioxide, and they end up releasing oxygen, and then we use after growing, we consume the food. When you consume the food, it's good in glucose, energy-giving foods. So what happens, which you call carbohydrates. So the glucose that we take in require us to breathe oxygen for it to break down such that it can benefit us. As we break it down, it gives us a bit of carbon dioxide, water, and even some energy that you are looking for in our bodies. So meaning that respiration is going to be the most utmost thing that we need as oxygen here. Let's say, look at that. The energy from respiration keeps us warm, allow us to move, enables hundreds of different reactions to go in our bodies. And note that respiration in some form takes place in cells of living things, not only humans. That one there, we are going to be advancing it in that response when you go to biology. Hope you are seeing that, how these science subjects are connected to one another, and you appreciate it. So now, another thing that we're going to look at. One, I want you to listen to this. Can you have that? Okay, just a moment. My battery is running quite a little bit low. Just a moment. Okay. Sorry for any delays, but I was trying to get more back power. Okay, guys, when you look at this, we have said that everything has its percentages and what. Can you really prove? Because how did we come up with these percentages, guys? That to know that nitrogen makes up about 78%, oxygen makes up about 21%. How do you prove to someone? Because in science, it's not a matter of you just speaking of statements. We need to come and then prove to people that actually this is how I performed a certain experiment and I found out actually the percentage of oxygen in air is 21%. How do you prove to people? The experiment is very easy. Look at this. What do you need? Let me try to explain using this illustration, if you allow me. Okay. Look at this. Okay. I want to use this diagram here to explain to you. What you're going to need, you need two syringes, gas syringes. Do you know what they call a gas syringe? A gas syringe, this is, I think everyone has ever received an injection. You know, that plastic thing they use to suck in the what? To put in the medicine before they inject it to is called a gas syringe. Without the needle. So what happens here? These gas syringes are used to measure gases. And then they have a scale. So what are you going to do? Listen, members. I have this gas syringe A, and this one I'm going to call it B. What do? I'm going to first empty one. Look at this one here. This A that I'm trying to square around, it is going to not be filled up with any bit of air. Any bit of air. So it's going to be empty, nothing. The other one that is going to be A, I'm going to just fill it with air, just put it in the air, suck in the air. And how much of air are you going to suck in? I want you to suck in about 100 centimeters cubed. How do you know that you have 100? There is already a scale that you use, which I know most of you are very familiar with using the graduated cylinders and so on. So what I'm trying to say, this one here, fill it with how much of oxygen? 100 centimeters cubed of air. So what happens here? Remember, you're picking air as then with everything that it constitutes of, the nitrogen, rare gases, and what? You just pick 100, your 100. So what do? You're going to need another thing, which you call a combustion tube. A combustion tube, it's just made up of glass. Yeah, it's not, doesn't need, it's as you see what can I tell you that you can use? Do you remember a test tube? The test tube is like, as you see a test tube, but the only thing for it, it is not closed at one end. It's open on either ends. Huh? So what do? You get that combustion tube, and then within that combustion tube, you are going to put some bit of copper wire. I repeat, copper wire, or you can use any other metal that you think of. But the easiest to find is going to be copper. So now, you get some small pieces of copper wire, you put them in the combustion tube, and then after putting them, you're going to connect these gas syringes, one to this end, this is A, you connect it to one end of the combustion tube. Then also you connect the empty one onto the other end here, as you see demonstrated. So now, remember, I'm using the word combustion tube. What do you mean by combustion tube? Combustion is all about a tube that allows things to burn in oxygen, isn't it? So now, what am I going to do? In between where you see, this is going to be my setup before I connect it to the heat source. So I use the heat source, which usually, it's a Bunsen burner. I'm going to put this combustion tube above the what? But as I'm heating it, listen to this, members. As I'm heating this combustion tube, what am I trying to do? When I'm heating, I'm going to be trying to press, look at this, listen here. I'm going to be pushing this stopper here. I'm going to be pushing this air to move above this copper wire. As it moves above this copper wire, it's going to be entering into this other gas range. And also I push this one again. So I'm going to keep on pushing air from one end to the other, pushing it like that for some good time. It can take about 5 or 10 minutes. Even it can go to 30 minutes. I'm going to be playing that game. Why? Because I want the air to pass over the copper wire as I'm heating it. Why? Because I need this air contains some oxygen, and that oxygen is quite necessary for what? For the burning of the copper wire. Are we there? I repeat the process. What was the process? Get 2 gas syringes, one fill it up with air of 100 centimeters cubed, and then another make it to be empty. Both of them connect them to either ends, both ends of the combustion tube that is having copper wire. What do you do next? Heat the combustion tube while you're passing over air from both syringes on top of the copper wire. You do it for some good time. What are you going to observe? All the air that you find there, any oxygen that will be in that air is going to be used to ensure or to make sure that all the copper burns. Copper what? Burns. So now what happens here? Meaning that if I had 100 centimeters cubed of air, do you expect that volume to be the same, to remain the same? No. Some of it is going to be used as what? In form of oxygen to support the burning of copper. So what will you observe at the eventual thing? You're going to see a drop in the volume of air. You are going to observe a drop in the volume of air. So why is it there? Because there is a drop because some part of air was used in form of oxygen. So how much was used? Look at this. Before I go through, I'm going to request you to first read for me here, these steps, like that. Read through those 4 steps, and then if you don't have, if you have any question, please you first answer, you raise the hand. Before. Someone is asking what I'm trying to say is that this experiment is trying to determine the percentage of oxygen in the air. That's the main role. That activity is to determine the percentage of oxygen in the air. Okay, so that's what you're dealing with, my dear. Marilyn, yes, having your hand up, is there anything to say?
Yes,
Marilyn?
I want to know whether it's true that the oxygen in this process turns black during the process. Is it true?
No. I'm going to explain it. Worry not, okay? Yeah.
Okay.
Yes, please. Uh-huh. All right. Alia? Alia?
Teacher, I can see that on the fourth step, sorry, on the, okay, like they said that you push back all the air into one tube so that you could measure and see, and that you're going to see that it's less than 100. But like, let's say you've pushed all of it back into one tube, right?
Mm-hmm. Yeah.
How are you going to know how much air is inside if air can be like compressed, because air can be fitted in any small volume or space, in any small space? Now what if you specifically put it on one, like a specific part of the scale, so that you can say that it's there? Because I'm not understanding how you're going to find out the exact amount of air that's remaining when you can basically put it in any position and you could still say that that whole space is filled with air.
Okay. All right. If at all I may respond before I take in a hand from Babidia. Just a moment, Babidia. Look at this. Before the experiment started, what did we do? We first made one gas syringe empty, not so? And then we had another one that was 100. It was filled. So that's how we first determine the first amount, isn't it? So you cannot calculate, you cannot easily determine it if you fill the air in either ends. No, it doesn't make, you cannot easily do that. You first make sure that all the air initially it's on one side. Why did we force it to cross on the other side? The reason why we did to want it to be passed on either side is to allow it to pass above the copper wire, such that it can be used for burning, isn't it? So here, you keep on swapping it from one end to another, but when you come to measuring, you ensure that one air is on one side. How do you ensure that it's on one side? Ensure that when you're measuring, ensure that one of the syringes is empty. You ensure that one of the syringes is what? Completely empty. Are we there? So that's how you determine it. And then Babidia, I'm listening to you now.
Teacher, I've answered my question. Thank you.
Babidia? Is she gone? Amal?
Teacher, like if the oxygen is in the syringe, can you see the oxygen?
No. Air cannot be seen by us. Air cannot be seen visibly by us, okay? Have you ever seen oxygen? You can never. We breathe it in daily. You can never see it, huh? But we only just look at its amounts. I think you ever blown air in the balloon, isn't it? It occupies space, but you cannot visibly see it. You know that air is there. You get it, huh? So you're going to just measure it, my dear, without seeing it. Once you want to see it, you have to use a microscope. Huh? Okay. Have you ever seen oxygen? Okay. All right, then. So now, I think Nachimera.
Teacher, I'm asking about the water vapor, because you say that water vapor is also a component of air. What happens to the water vapor? What happens?
Water vapor?
Yes.
I'm going to explain a little bit. Worry not, huh? As we are manipulating. Huh? I promise I'll explain to you later. Okay. Rania is Rana. Tom Sange.
So teacher, I'm asking if the use of the heat is to show that the oxygen is going to be used up and the remaining parts of air will go to that other tube.
Actually, to answer you hurriedly, for oxygen to combine with copper, you need some bit of fire, heat. I think, okay, usually we say that oxygen supports burning. You know, air has oxygen. Have you ever found your charcoal, dry charcoal, when it is burning because it's next to oxygen? Are you sure? Charcoal, you find a sack of charcoal when it's burning.
No.
Okay, so now what happens here? For it to combine, yes, you can have oxygen around it without combining. For it to combine, condition the attach, you have to first you have to ignite. I think everyone has ever tried to light a sigiri, isn't it? What do you do? First put on some bit of fire, and then as the fire goes on, you ignite, or you aid the process of them combining. So here, the reason why we use the heat is to provide enough conditions for copper wire to combine with oxygen. So someone talked about that the oxygen turns black. No, you know, the copper wire, these are the ordinary wires that you find in the sockets. They're always brown in color. As the more it combines with oxygen, it's a chemical change. I hope you remember, Mr. Nasmore, also any other teacher took you through permanent or temporary changes, isn't it? We say that whenever there is a chemical change, there is formation of a new substance. The copper is a chemical. Oxygen is also a chemical substance. When the two combine with one another, they form another compound. That compound, how do you know that they form a new compound? You are going to see a change in the color of what you had initially. The brown copper wire is going to turn black. For some of us, I think you've ever seen electric sparks. Huh? Those electric sparks, whenever they spark, what happens to the color? What happens to the colors of the wire? Whenever they blow, you see them turning black. Why? Because they produce heat. The heat helps the brown copper wire to combine with the oxygen to form a new substance, which we call copper 2 oxide. It's called copper 2 oxide. Is the black color that you see. It's not the oxygen that becomes black, it's the new substance that is formed that becomes black. After what? The copper wire combining with the oxygen in the air to form copper 2 oxide. I think the idea of explaining there is no oxygen that is black, my dear. Gases are usually colorless in their nature. So now here, I do believe that most of us are comfortable with the procedure. How are we going to use what you observe to calculate the percentage? One, here, we're carrying out this experiment. What are you going to do? You are going to determine what? One, already we had the initial volume. What was the volume of air that remained? Already we know what we had initially was 100. Okay, so when you, after doing all the many rounds that you may think that you have done, when you're passing over, how are you going to calculate the volume of air that has been used up? Why did the volume of air decrease? What is the percentage? These are questions that you must answer by yourself, which I do believe is going to be easy after my explanation, and we shall end on that before we look at that. Look at this, people. You may observe that the volume of air which remain is less than 80%. I repeat this one here. You may observe that the volume of air that after you passing over the air above the copper is going to reduce by Oh. All right, guys, we apologize. It was a glitch. The Wi-Fi was locked up because of the power. But I was trying to say that the time is also running down. Can we start from there the next time? We do some calculations. We pose a few questions. We do how we can calculate using that experiment. And I'm seeing some hands up. The burning questions. Asimwe. Hey, Asimwe, no, right? No, I'm unmuting them. It's okay. Okay, so once you have something to say, you just simply unmute yourself, huh? I'm waiting for questions, people. Asimwe? Shifa, you have your hand up. What's going on? Unmute yourself, please.
Teacher, you said on the video you showed us, they say that carbon dioxide helps marine animals make shells. How?
Hey, you know these shells that are like, you see that one for snails, huh? They're made up of calcium carbonate. Huh? Have you heard of the coral reefs in geography?
No.
Yeah? Hey, you haven't
No.
heard of them? Okay. Okay. Those kind of shells that you ever find, the shells that the shells are made up of calcium carbonate. Huh? So calcium carbonate for those shells to be formed, they need carbon dioxide because carbon dioxide is converted in form of a carbonate. So that's why we say that it's necessary for that, my dear.
Okay, thank you, teacher.
Welcome, please. Shifra, is it Shifra?
Excuse me, teacher. I was asking, how can we know that the oxygen in the syringes
How do you know?
it's filled up, it's used up?
Yeah. Moment, please. Okay. Repeat the question, my dear.
I was asking, how can we know that the oxygen in syringes in the syringes is used up?
How do you know that the oxygen
Teacher, I have one question, and I also would like to answer the person who was asking. You know that the oxygen is used up when the copper is burning. And then the question that I have is that basically, so this experiment is basically proving or showing that the percentage of oxygen in air is 21%.
What we are about is that we are going to pass with it.
I beg your pardon?
Teacher, you aren't very clear.
Yeah, like I can't hear you clearly.
I can't hear you.
I can't even see you.
So you're not hearing.
Teacher, yeah, they are complaining. Teacher, they are just good. Just it's muted. Then Alia is muted again. Yeah.
Yes, because what teacher?
Alia, you're speaking slowly. Teacher is not hearing you. Alia, you're very low.
No. I was actually shouting. Okay, I don't know why it's not working. Like, okay, fine. Now can you guys hear me?
She's actually shouting, but she doesn't know why the voice is not reaching.
Alia, we can hear you.
Yeah, like I was asking.
Alia, we can hear you.
Alia, now are you hearing? Are you hearing, teacher?
Yeah, no. Nope.
Are you at school?
Nope, I'm not hearing, teacher.
Now she's not hearing you, but she's hearing you.
Very clear.
Alia, are you hearing teacher now?
Yes.
Yeah, she's hearing you.
Okay, so can I ask the question or?
Yeah, repeat the question, Alia.
I was saying, so basically the experiment is showing or proving that oxygen does, like, okay, the composition of oxygen is 21%.
Okay, so guys, we have agreed that next time when you come in, I'm going to prove it.
She's like I mute.
Trying to say that earlier.
Yeah.
Next time that we come, I'm going to demonstrate to you how do we come about the 21%, because what I see time does not allow us in, and then some people already switch off whenever we get past time. You get it, huh? So I hope that next time is where we're going to start to see the calculations, the formula, and how we prove it, huh? Is it like Chen?
Thank you.
Chen, can you unmute yourself, my dear?
Okay, so teacher, my question is also about the experiment. Assuming after step 3, our answer is 55 centimeters cubed. Then, like, if we do step 4 and I get something related to that or the same, does it mean that the experiment was successful?
No. Okay, the experiment, like we have seen that when you get pure air, we are going to find that the amount of oxygen that you find in pure air must be 21%. Your answer must be close to 21%. You can get something like 20 point something, as I'm going to explain when you come back. Huh? So, unless when you pick air that is from industries that contains less oxygen, huh? That's when you can get a very answer that is quite lower than expected. Huh? So, all what you're saying is going to be, all our hearts are going to be settled when we do some, about 2 or 3 examples. Huh? So you don't need to worry. So next time we meet, we shall be all clear. Is it okay? Shifa, okay, be the last one.
Teacher, I have another question.
Yes, my dear.
Like on you said the video, yeah? It was saying that air helps to form rain by the process. Then you told us the process is precipitation. But I have searched, they are giving us also condensation and moisture. Are they correct?
Okay. So when we are going, okay, as you see the video is going to keep on continuing to water. We are going to cover what they call the water cycle. Okay. So there are many, water cycle, evaporation, condensation. So alternatively, condensation can be known as precipitation. All right, then thank you so much.
Oh.
But after, okay, what I can say to be so clear to you, after the water condenses, the way it condenses and then it's converted back into rain, that process is what they call precipitation. Is it okay?
Yes.
Okay, the hands are just going in high. Namagembe, Shifra, I gave you a chance. So Namagembe, say something. Asha? Namagembe. Okay, she's just cut it. All right, then so we can call it a day. Have a blessed one. We meet again soon. Huh?
Thank you, teacher.
Thank you, teacher, for teaching.
Thank you, teacher. Bye, teacher.
Thank you, teacher.
Nice weekend.
I appreciate it.
Thank you, teacher. Bye.
Question.
Hmm?
Bye.